So, welcome to module 5.6 and we will be doing a demo of project 06. We have written an assembler. So, let us just look into the directory of project 06. So, I am opening up this assembler. So, go to the tools and open your assembler here as I am showing here. Then let us go to the projects. So, when you say this add, so I have written the assembler, this add.asm will be already available to you as you see here. This is your add.asm, sorry, it should be in WordPad. This is your add.asm. Now we can see I have generated this program that I have written, the assembler has basically generated this add.int, and there you will see let us see this notepad again. Oh, sorry. To see the WordPad, yeah, right. Now all the comments are removed here. So in add, you can just see add was basically having the add had the comment, and all those things are removed in this add.int. So I have decommented and right, and then this has created this add.hack, right. So that again we will remove that and these are these 6 binary comments. Okay, now how do we do this? So there is an automatic assembler that is provided as a part of your thing. Now in this automatic assembler, that is, this will do the assembly for you. What we do is first we load the file. So I wrote add.asm. I also go and load the comparison file. This is add.hack that you have generated as a part of your assembly program. So that is this. Now we will make this assembler is already tested golden reference. Now we will ask it to assemble. So I tap this. So it is doing one by one and says, yeah, it is done, right. Now let us go and do something more. I can load another file. Now this is there are multiple directories in this 06. We have add, max, pong, etc. So let us take some max. Max has one with label and one without label. Let us take this one with label. I have loaded the source file. Now I can also load the comparison file for max again, load comparison file. Now we do this double arrow will automatically do for you. At or not is 0 at m. So instruction by instruction, this is assembling. Note that output first was not, this is just a label. And the comparison is success. So you can check this. Now the next thing is, let us go to some other file here like Pong. Pong is a very big program. So let us take Pong with labels, and let us take the comparison file again, that pong.hack. I have created this. Now let us do, and this will take enormous amount of time, right. There are 27,000 instructions, so only tomorrow we will finish. So now how we can do this? For running, there is something called fast translation, right, fast translation, that is all, it is done. Okay. So I will again do that, load the source file which is pong, load the comparison file which is again pong. Now go to this run and say fast translation, test translator and give it. There are 27,000 instructions and it worked, right? So this is how you verify. So you write the assembler, take all the .asm files in your in add, max, pong and rect, there are asm files. Now you run your assembler on each of these files and that will give you this hack and intermediate and hack file. Similarly for everything, and then now you open this assembler which is part of your tools, right? There is an assembler, inbuilt assembler that is given to you. This is part of the tool, and then go to each one of those files. You load the ASM file, you load as your source file, and you also load a comparison file, which is the file that you have created, and then you go and run and ask it to fast translate and or translate it step by step and see whether this matches. And this is the way you validate your assembler, right? And if it works here, I think your assembler is perfect. So happy assembly, and by the end of this I think you should spend the 2-3 hours to get this assembler pakka. You can easily do that, and then that means you have written the first system program for your system stack, right? Now you have made a machine, and you have made that machine more sensible by saying that now at least I can give you a mnemonics environment. You can write assembly programs in mnemonics which is more human readable, and I have a software which will now convert it into binary and which can run on my machine. So this is the first step, and I hope you are excited about this. And now we will go into the next stage of understanding what a virtual machine is, right? Understanding a virtual machine is very interesting, and I hope you will enjoy doing it. So before we go to module 6, my request is please complete project 6, the assembler, so that a complete understanding of the assembler is very important for you to appreciate how virtual machines work. Thank you.